Welcome to the video for Chapter 12 on Solids, Lesson 3, Pyramids and Cones. How do we find surface area and volume of pyramids and cones? We're going to go ahead and get started with the formulas. We're going to be looking at surface area for pyramids and cones first. So in taking a closer look at the surface area for pyramids, notice that it's 1/2 the perimeter. We're familiar with this perimeter. Then this cursive L stands for the slant height. We're going to take a closer look at that in a second. And then capital B is still the area of the base. So that's for pyramids. Remember, their base shape of the pyramid could be a variety of things. So that's the same with this capital B. The cones have a surface area formula of pi times the radius times L, still this slant height, which we'll take a look at in a second, plus pi r squared. All right, let's take a closer look at the slant height. I have an example of a pentagonal pyramid and a cone. In purple here, this is the apothem on the pentagon. So I need you to visualize this purple is labeling the bottom, the pentagon that is on the ground, that's on the bottom of this pyramid. The H represents the height of the pyramid. So it is going vertically from the center of the pentagon up to the vertex. So this is a three-dimensional value. The A is flat, two-dimensional on the ground. The H is vertical, three-dimensional coming up and meeting at the vertex. The slant height of a pyramid is located down the center of one of the side triangles. It is the height of the triangle on the side, and that could be useful depending on what information we are given if we need to find the slant height. It is, again, going down the center of the sides of the triangle, on the triangle sides of the pyramid. One thing I will also point out to you is that if you take this from the height over to the midpoint, really where the slant height is coming down, you do end up with a right triangle. So from the height over slant height, you do end up with a right triangle here, and that's going to be very, very helpful if we need to maybe find the slant height or find the value of the height depending on the problem. The cone is very similar, except for instead of the apothem going on the base on the circle, that's the radius. The height still is that vertical three-dimensional measure. It's coming straight up. And then the slant height is that slanted height of these cones and pyramids. So that's going to be on the side. Same thing applies with the right triangle that gets created with the height and the slant height. We have the right triangle there. So the slant height in both of these would be the hypotenuse. The slant height in both of these would be the hypotenuse of the right triangle. The base of this triangle would be the radius. The base of this triangle over here is going to be that apothem. So that might be extremely helpful if we're finding missing side lengths. The formula for volume of each of these, notice, is just 1/3 of our prisms and our cylinder formulas for volume. So 1/3 of a prism is the space that a pyramid takes up. 1/3 of a cylinder or a can, 1/3 of that is what a cone would take up. So it's 1/3 times the area of the base times the height, 1/3 pi r squared h. So no slant height here, just the h, but it's possible we might have to find the value of the height of the pyramid or the cone, depending again on what is given. Okay, jumping right into some problems here, it looks like we're going to be finding surface area and volume for the following solids, and unless it's noted, the base shape is going to be a regular polygon. In this first example, it is not a regular polygon because I have a right triangle with a side of 6 and 8. I do not know what the hypotenuse is over there, but it's definitely not an equilateral triangle because I have a side of 6 and a side of 8. So in this case, it is not regular. That does make a difference because in this case, we actually are not given the slant height. I do not know this measure here, the slant height. Remember, the slant height is on the side of the triangle there. I don't have that value, and I could find it if I had enough other given information. I could find the slant height because I know that the height of this, so this side of the right triangle here is 6. The problem is I don't know what this value is, and I can't find it because it's not a regular triangle. If it was a regular triangle, we might be able to do some work that we were covering with the area of regular polygons. But in this case, I actually don't have enough information to find the slant height, and you'll see plenty of other examples where we do have enough information to make this a little bit more clear. But in this case, I don't have the slant height of this pyramid, so I am not going to be able to find the surface area. I'm only going to be able to find the volume using the area of the base and the height 6 of the pyramid. Just to take a different glance at it, sometimes it can be easier to pull this right triangle out of the pyramid and take a closer look at what information we are given. I'm only given the height. I don't know the slant height, and I also don't know this length here, again, because it's not a regular triangle as a base. So I can't find the slant height, so we can only find the volume. So let's go ahead and calculate that out. So volume formula for a pyramid is 1/3 area of the base times the height. The area of the base is a triangle, so a formula for area of the base of a triangle is 1/2 base times height. So 1/2 6 times 8, or 8 times 6, whichever one works for you. And so that ends up equaling 24. The height of the pyramid itself is 6. That's what this H stands for, the height of the pyramid. So plugging that into the formula, 1/3 times 24 times 6 ends up being 48. It is volume, so your units should be feet cubed. So whenever we have the numbers that we need, again, we're just filling it into the formula. There's not a whole lot of extra work, but finding the area of that base does require you to pay attention to what shape the base actually is. So in each of these examples, we're going to have to make sure that we have the slant height as well as the height of the pyramids or the cones, and making sure that we also have, well, that's what we need really for the formula. We need the slant height and we need the height. We will need the perimeter also, but that should be given. So there are going to be problems where we might have to find the height or the slant height. And it looks like in this one, we're going to have to find the height of the pyramid. This 10 is on the side. I know that because it's a solid line. It's not dashed going through the pyramid. It is a solid line on the side of the pyramid. So that's going to be my L value. So I have my slant height. I need my height. This is a square because it's not noted being anything other than regular. So it is a regular polygon. So that means that this height here is splitting that in half. And so that ends up being 4. So if I pull this right triangle out, I need the height. I have 4, and the hypotenuse is the slant height, which is 10. So just using Pythagorean theorem to find the height of the pyramid to be 9.17, and then I can use that as my H value, 10 as my L, and then I'll use my 8 as needed for perimeter and area of the base. So now I'm just going to go through and start using my formula. 1/2 times the perimeter times the slant height plus the area of the base. So I need P, I need L, and I need B. Perimeter around a square is 8 times 4. The slant height was given as a 10. The area of the base is 8 times 8 because it is a square, it is a rectangle. So surface area ends up being 224 once we plug these values into my surface area formula. Now the volume is where we actually end up using the height that we needed, that we had to calculate using Pythagorean theorem on the last slide. So volume equals 1/3 area of the base times the height. We already found area of the base over here in the surface area work, so that's where the 64 is coming from. And this H we found using Pythagorean theorem with the 10, the 4, and finding the value for the height. So plugging that in as necessary, we get 195.63 cubic inches. Now, for the rest of these problems, I'm going to go ahead and walk you through the finding of the height or the slant height, depending on what is missing. But then we're just going to quickly move through actually using the formulas for the surface area and volume of the pyramid, or moving into the cone also. The slant height or the height work should all be revolving around Pythagorean theorem. So let's take a look at this one. I have the height of the pyramid because it is a dashed line going down through the middle. I do not have the slant height, but I do have the distance from the height out to the side. That's going to be in the center. So I know even though this is not a regular, even though this is not a square, it is a rectangle. So I can easily figure out that this is going to go to the 4. So this is in the middle. It's going to be a distance of 4. The height is 10, and I just need to find L, which is the hypotenuse. So we use Pythagorean theorem. So my slant height, the value of it's the height of the triangle on the side of the pyramid. That slant height there is going to be 10.77. Then we just go through and plug in the appropriate information into the formula. In this next one, it looks like we are given the slant height. Again, I know this because it's a solid line on the triangle. I am missing the height of the pyramid going down through the center. It looks like I have a hexagon here. So the 5.2 is the apothem, which will also be the distance from this point out to the bottom of this slant height. That will help me figure out a right triangle to find the height of the pyramid itself. So this green triangle, I'm finding the height. I know this distance to be 5.2 because that's the apothem no matter which side of the hexagon it's going to. It's going to be 5.2. The slant height is 11. So we're missing the height, and we can use Pythagorean theorem to find that the height is 9.69. And then again, we use those numbers. Slant height's 11, height is 9.69, and we use them as necessary in the formulas. The cones are going to be pretty much set up the same way. If the side of the cone is labeled, then that is going to be the slant height. The height of the cone should be, again, a dashed line going down through the middle. So it looks like in this cone, we have the slant height, but we do not have the height of the actual cone. So we'll use Pythagorean theorem to find that. This one ends up being pretty straightforward. 9 is the hypotenuse of the right triangle. 4 as the radius is the bottom leg of the right triangle. And the height is the other leg of the right triangle. So we get the height to be approximately 8.06. And we will use that in the surface area and volume formulas for a cone. Notice that the formulas are a little bit different now that we're using the cones. We have a pi r squared, pi rl, still have the h with the volume. We're using the slant height with the surface area. Looks like we have the height in this cone because it's a dashed line going through the center. The 12 is representing the whole diameter, so we will need to keep that in mind for our right triangle, also for our formulas that use the radius to help us find the slant height, because we do need the slant height in order to find the surface area of the cone. So the L is my hypotenuse, the 8 and the 6 are my legs, and we get a nice even 10 for the slant height of this cone. And again, just using our formulas, 10 is the slant height, 8 is the height, 6 is the radius, and so we use that as necessary in our formulas for surface area and volume. In this next one, again, I'm missing the height of the cone. It doesn't matter how the cone is given to you. This one's kind of on its side here, but this is still considered the height of the cone. 5.2 is the slant height. 3.2 is going to be the radius of the circle, but it's also going to be that leg of the right triangle. So we use Pythagorean theorem to figure out the height of this cone is approximately 4.1. And we use those values in our formulas. Last one, looks like we have the height and we have the radius is 10. So this right triangle here will help me figure out the slant height, which after plugging in 10 and 24.5 for my legs ends up being 26.5 for my slant height. So we will use 26.5 as the slant height, 24.5 as the height of the cone, and then 10 as the radius for the circle. Plugging those values into the appropriate formulas, we have our answers for surface area and volume. This concludes the third lesson for Chapter 12, Pyramids and Cones, and how do we find surface area and volume for pyramids and cones. If needed, we use the Pythagorean theorem to find the height or slant height. Then we use the appropriate formulas. Thanks for watching.